Yesterday we took a look at composite figures, so figuring out the total area or total volume of an object that has more than one piece. We're going to be doing something similar to that today, but we're going to focus on a few specialized shapes, both prisms and pyramids. So let's get going. So you should have this note in front of you. You can fill it out as we go along. So the surface area, now that sounds a little different than area. It's similar, but it's not exactly the same. The surface area of any three-dimensional object is the number of square units needed to cover all sides. Now, area is a two-dimensional thing, right? So if I have the area of a square, it's just the area of that two-dimensional object. But if I have a three-dimensional object, what is surface area? Well, what surface area is surface area is the area of all the different sides. So you see if this is a kind of a rectangular prism, it has 6 different sides. If I were to calculate the area of all 6 sides, that would be altogether the surface area. Okay, and surface area, just like area, is stated in square units. The surface area of a triangular prism is calculated using the formula below. So let's take a look at that. So SA, short for surface area, is going to be 2 times the area of the base plus area of face 1, area of face 2, and area of face 3. Take a look down here. This triangular prism, we can tell that it's triangular prism because at both ends, both bases, we have triangles. And we know it's a prism because what we have is a two-dimensional shape stretched out. Anytime you see the word prism, what you're just looking at is any two-dimensional shape that has been stretched out into 3 dimensions. Okay, so you can have a circular prism, although we tend to call that a cylinder. You can have a triangular prism. You could have a square prism, although we just tend to call that a cube. But all of these things are prisms. But let's get back to the triangular prism. So this is the total surface area, this one big formula here, but there's a lot of things that need to be calculated separately. So we need to find out what the area of the base is and the area of each of the 3 faces. We're going to do that separately, and then we'll add them all together. Let's take a look at it. The area of the base. Now, remember, the base means the two-dimensional object that has been stretched out. So that, since this is a triangular prism, that means it's the triangle itself. Sometimes when you see the word base, you might think, oh, it's whatever it's sitting on. But that can't be it, because of course we could move this three-dimensional object around and have it sit on any of those 5 faces. So when we say base, we mean specifically that two-dimensional object that has been stretched out into the prism. So that's a triangle in this case. So what is the area of that triangle? So we know the area of a triangle is base times height over 2. In this particular triangle, we know that the base is 6, the height is 8. So we're going to plug that in. That's 48 over 2. So we have an area of 24 centimeters squared. Now let's talk about, and now there's going to be 2 of those. We can multiply those later. What about these 3 sides? So we've got the one on the back here, we've got the one on the front, and we've got the one underneath. So let's call them just face 1, 2, and 3. So area of face 1 on the back here, we can see that it's 8 high and it's about 10 long. So that's going to be 10 times 8, or 80 centimeters squared. What about face 2? Okay, so it's 10 long. And then what about this length here? This length doesn't look like it's actually been labeled. Oh, actually, here it is. It's hard to see, but it is labeled here. Even if it wasn't labeled, we could figure it out because this triangle is a right angle triangle, and we could use Pythagorean theorem to find it using these 2 sides. A squared plus b squared equals c squared. I think it actually has been labeled for us, and it would work out to 10, so we're good to go there. So length times width, it's 10 by 10. Okay, so that's 100 square centimeters. And finally, the one underneath is 6 by 10. So that'll be 60 centimeters squared. Great. Now what's the surface area? So now we have two bases, right? Two triangles, and they're each 24. So we're going to multiply them like that. And then we're going to add all the other three faces. All right, so that's going to be 240 plus 48 is 288. So the surface area equal to 288 what? Centimeters squared, right? So surface area is measured in the same units as area. It's going to be square units. And again, you may come across questions where they do not give you, let's say you've got this as 8 and you've got this as 6, but you don't know what this side length is, and you do have to use Pythagorean theorem to calculate it. You will come across questions where you have to do that. So that's surface area. That's thinking in two dimensions. Even though this is a three-dimensional object, we really are measuring two-dimensional area. But you guys also know about volume. And the volume of an object is the amount of space it occupies. You've learned about this before. Volume is measured in cubic units. So if we're looking at meters, it's meters cubed. Let's talk about the volume of a triangular prism. Well, actually, the volume of any prism is calculated like this. The area of the base, so that's whatever the base is. In this case, again, it's a triangle. So the area of that base, and then multiplied by the height. And then the height is just basically how long has this two-dimensional shape been stretched out. Okay, so again, when we see the word height, we might think of, okay, it has to be standing on end, right? So if I've got a cylinder like this, then the height is, this thing right here. But what if the cylinder was laying down? Then what would the height be? It would actually be the same thing. That would be the height. So this can become confusing when you see something, it's called a height, but it's not actually, vertically standing up. The height is just the distance that that two-dimensional object has been stretched out. So it's going to be area of base times height for the volume of this triangular prism. But first we're going to have to calculate that area of the base first. So this is the base here is a triangle. And luckily this time we've already been given both the base and the height. So we're going to just plug those in. We got a base of 5, a height of 2. And that gives us an area of 5 meters squared. Volume is the area of that times the height. So we're looking at 5 and a height of 7. If you hear a ringing sound, that is my dog who really, really wants to go outside. But he's going to have to wait. 5 times 7 is 35. And then that's in meters, but it's in meters cubed. So that's volume, right? And this kind of makes sense if you think about it. If we were to plug units in here, this would be 5 meters base times 2 meters height, and that meters times that meters becomes meters squared. And then here we've got 5 meters squared times 7 meters, and meters squared times meters is meters cubed. So I know we don't put units in our formulas when we're solving, but maybe that kind of helps it make sense a bit for you guys there. Okay, so that's how we do the surface area and the volume of prism. Remember, surface area is two-dimensional, volume is three-dimensional. All right, so I'm not going to spend quite as much time with pyramids because it's actually very much the same concept. We're just looking at a different shape, and so we'll be working with different formulas. But the concept is very much the same. Now, we're going to be working with square-based pyramids. Now, because we're dealing with a three-dimensional object, they can be difficult to draw, pyramids, and so when you're looking at this, it might appear as though that base is not actually square, but we're going to assume that it always is. Unless our textbook question says otherwise, unless it says something like this is a triangular base pyramid or whatever. Okay, so on these square-based pyramids, there are 4 identical or congruent lateral faces. Okay, so that means that any face that's not the base, any face that's not that square, is going to be called the lateral face of the pyramid. And on a square-based pyramid, they should be identical. They should be congruent, the same, the same dimensions. A square pyramid has 4 congruent triangular faces and a square base. The surface area can be calculated as the area of the base, which just so happens to be a square, times 4 of the areas of the triangle, because again, each of those triangles are identical to the others. So let's take a look at this. Now, in this case, we're not even working with a diagram. We've just got a description, and that's fine. So a pyramid has a base of 7-meter sides. The lateral faces have a height of 8 meters. Let's find the surface area. So first things first, always put the general formula. So we've got the area of the base times 4 of those triangles. Now, let's go over here and do some calculations first. What is the area of the base? And what is the area of each triangle? So the base is a square, and it says it has 7-meter sides. So squares are s squared. The side length is 7. Then we're looking at an area of 49 meters squared. Triangles, let's see, the lateral faces have a height of 8 meters. Okay, so let's see, triangles are base times height over 2. They'll have a lateral height of 8, but what's the base? Well, let's think about this for a minute. It doesn't hurt to draw it out if you don't have it in front of you. So let's do this. So here's how I like to draw a pyramid, a squared pyramid. What you can do is draw kind of a square, but make the bottom uh, length just a little bit longer, so it ends up becoming more of a trapezoid. Then pick a point kind of up here and just connect all of the corners to that point. Kind of like that. And then just connect all the bottoms of the base. And if any of those are going to fall, out of sight, as in like if this was a real pyramid, you wouldn't see it, then you can draw like a dashed line just to demonstrate that. So let's think about this for a second. If this square base pyramid has base length, bases, base sides with a length of 7, that means that the base of each triangle will also be 7, right? And then the height, that's the lateral height, so that's the height along the slant. Sometimes that's also called the slant height, is given as 8. So that's going to be 28 meters squared. Okay, so now let's plug that all into our original formula. Surface area is the area of the base, 49, plus 4 of those triangles. So that's 28. So let's see, 112, that's 161 meters squared. Again, surface area always in square, 2-dimensional units. The volume of a pyramid uses this formula. I always found this kind of a neat formula. To me, it seems sort of random that it would work out this neatly, but the volume of a pyramid is actually just 1/3 times the area of the base times the height. Now, that might look familiar to you. Area of the base times the height is just the volume of a prism. So if the base on this is a square, really what we're looking at is if I could fit that pyramid into a cube of the same dimensions. So just imagine a cube that this pyramid fits neatly into. The volume of the pyramid will occupy exactly 1/3 of the cube. It's kind of weird, eh? Anyways, that always kind of weirded me out that it was exactly a third, but here we are. That's the formula. That's how it works. All right, so volume of a square-based pyramid. So there's the formula. Let's take a look at an example. The height is measured from the vertex of all lateral sides to the center of the base. Okay, so when we talk about the height of the pyramid, as opposed to the height of the triangle, we talk about the height of the pyramid, we're picking the point directly in the middle of the pyramid here. Okay, so this is halfway across the pyramid in both directions. That would be the midpoint of both of those two lines. From there, directly to the apex or the peak of the pyramid. That's the height of the pyramid. Now, in this case, we're given 10 centimeters as the slant height, and 8 centimeters as the complete base length. How are we going to find the actual height of the pyramid? So you almost have to imagine a right angle triangle that's cutting right through the middle in the center of the pyramid. So I've redrawn it out here, and you can do that yourself as well. We can see we've got 10 as the slant height. 4 is going to get us halfway across the bottom of the pyramid, so that's half of 8. And the height is what we don't know. Of course, you can see this is a right angle triangle, and so we're going to use Pythagorean theorem to find that. So square root of 84, which works out to, let me grab my calculator here, it's going to be 9 point something. It's 9 point, I'm going to keep some decimals here because we're not at the end of the question yet. 9.165. All right, so let's plug. Oh, and okay, so now this is the total volume. We've calculated the height, great, but we still don't have the area of the base. The base is a square, side length 8, so that's 64 centimeters squared. So now let's plug it all in. Area of the base is 64. The height is 9.165 approximately. And that's going to give us a total volume of, drum roll, 195.5 approximately. That's been rounded. And of course the units there are, oh, not meters, but centimeters cubed. Perfect. All right. So go ahead and try your homework. Don't forget, always start with the general formula. And if there isn't a diagram provided, please draw one. I know drawing pyramids can be difficult, but again, like I said, if you start with that trapezoid, make a point somewhere up there, you'll end up with something like a square pyramid that you can work with. All right. Best of luck, guys.